Thank you. 19. Give me 2 more maybe. 13. Oh, that one's kind of a different one, but okay. I'll do it. Give me one more, one that like you're actually finding the area of a circle. None of those shaded problems, none of those? This was a beefy homework. It was a good homework. Number 30. Okay, I'm going to start with those 3, and if you think of another one that you want me to work, you let me know. Okay? Starting with number 13. Solve for x. Do you know what that equation is? Do you know what it is? But it has to have something to do with circles. Anyways, I'll let you think about that. Regardless of what the equation is, to solve for x, this is really just an algebra problem. We're going to subtract by from both sides, and then we're going to divide by a. Kind of silly. Okay, next one you asked about was 19. The areas of 2 circles are in the ratio of 16 to 9. Find the ratio of their radii. So I give you the area. And this problem comes from today's lesson because that doesn't have a pi in it. That's not the area. The ratio is 16 to 9. So let's say the area was 16 pi to 9 pi. The pi's would cancel. But I do want you to think about what would you do if I gave you area and you wanted a radius. So if I gave you area, pi r squared, and I wanted you to get a radius, you would do the opposite of squaring. You would square root. So if we square root 16, then we square root 9, which is really kind of getting into today's lesson, then the ratio would be 4 to 3. So that's kind of all that was talking about, is area is 2D, and you want to make it 1D. Okay, the next one, number 30. I'm going to use the picture that's already there. Find the area of the shaded region. So that is a rectangle, area of the rectangle, minus the area of, how many circles do we have there? 1, 2, and a half, yes. So the area of 2.5 circles. Okay, so let's do the area of the rectangle first. The radius of those circles is 3. The radius is 3. So the diameter is 6. So this is 6, 6, and 3. So base times height, or length times width, we've got 12, 13, 14, 15. It's 15 by 6. So the area of the rectangle is 15 times 6, 90. And then we want the area of a circle times 2.5. So I'll just go ahead and put 2.5. And now let's find the area of the circle. Well, pi r squared. The radius is 3. So 9 times 2.5 is 22.5, but you could also put it as a fraction. So this would be 90 minus 45 halves pi, or 90 minus 22.5 pi. Those are both acceptable answers. What do you think? That one okay? Did you come up with another one? Okay, let's move on. And you can title your notes, Area and Perimeter of Similar Figures. There's some good news here. We've already done this lesson in the similarity unit. We're just going to do it again in the area unit because now we know how to find the area of things. But the lesson's really not going to be any different. So this is a review. Ready? Why not? All right, we're going to discover it again, but we kind of have already done this before. Let's see, I haven't called you all's names in a long time. Let's do Taha, find the perimeter of this one. Brandon, find the area of this one. Albert, find the perimeter of this one. And Adriana, find the area of that one. All right, 14, area 10, perimeter 42, an area 90. Okay, Yeji, what is the scale factor that gets me from here to here? What's the scale factor? Very good. 6 divided by 2. Second over first. Very good. The scale factor is 3. Now I want you to find the ratio of the perimeters. Ratio just means divide. Let's divide those perimeters. Are you ready? 42 divided by 14. Whoa! 3. Ratio of the areas. Ratio just means divide. 90 divided by 10. 9. So now we need to make a connection. The scale factor is 3. So that's like saying 3 to the 1. The ratio of the perimeters is also 3 to the 1, but the ratio of the areas, very good, is 3 to the 2. 1D, 1D, 2D. Remember that lesson now? The 1D and the 2D? So that's what we're getting at with this. So this is old, but I'm reminding you. The ratio of the sides, that's 1D, it's A to B. Perimeters, 1D, A to B. Areas, 2D, so it'd be A squared to B squared. Sometimes people call this, the scale factor is K, the ratio of the perimeters is K, and then K squared. Kind of like 3, 3, and 9. Okay, since that's old news, we're going to keep going. Let's go do volume in irregular 3D objects. That'd be fun and challenging. Are you saying I'm not challenging you? I'm so sorry. I will try to challenge you later in this lesson. Probably won't work. We'll do 3D figures next, okay? All right, so let me start calling names. Minjung, ratio of the sides. Helaman, ratio of the perimeters. Tahani, ratio of the areas. It's nice to have easy every now and then. Good, 4 to 7, that will work. 4 to 7, you can use a colon or a division sign. Helaman, 4 to 7. And Tahani? So Helaman, did you find the perimeter and then find the perimeter and then divide them? Quan and helium, you're getting off topic. Anyways, Good job, Tawny. Thank you. 4 squared is 16. 7 squared is 49. What I wanted to get across is you're not actually finding the perimeter. Because you know the ratio of the sides and the ratio of the perimeters are the same because sides are 1D and perimeter is 1D. They're both 1D, therefore they have the same ratio. Yes, we did have to simplify. Can you simplify 16/49? No. Ratio of the areas, you just square the ratio of the sides. All right, let's keep going. Given the similar hexagons, find each ratio. I'm going to do the ratio of the areas because there's nothing to that one. The ratio of the areas is 100 to 169. If you wanted to write them the other way, that would be fine as well. Jenny, do the ratio of the sides. Well, and the ratio of the perimeters because let's just be honest, that's the same answer. So Jenny, what is the ratio of the sides and perimeters? Square root of 100 is 10, very good. Square root of 169 is 13. So that's all there is to it. We're going to move on because I think we all get it. Given two similar rectangles, find the perimeter of the first rectangle. Oh, sorry. I thought Jenny typed that. It was Austin. Sorry. Austin, you're mean. Jenny, I'll give you another one. Yes, it's yours. The cool thing is about this one, guys, is sides are 1D, perimeter's 1D. So you can set up a proportion and cross multiply. You don't have to worry about, ooh, this is a side and this is a perimeter. Do I need to convert? Do I need to do anything? No, you don't have to do anything. You can set up a ratio, a proportion, and cross multiply. So whenever you're ready, Jenny. This is 1D, this is 1D, and so you are allowed to cross multiply. What'd you get, Jenny? Yes, very good. The perimeter is 92 inches, and we didn't even have to calculate perimeter per se. We just used the ratio. Very good. Okay, next one. Given two similar octagons, we could actually care less that they're octagons. We don't care that they're octagons. Find the area of the larger octagon. So the good news is you're not actually having to find the area. Since you know they're similar, you can use proportions instead of using the area formula. So that is good news. Quan, whenever you're ready with the area, let me know. You can type it in. Let me set y'all up. 9 is to 15 as 45 is to x. Now this is different from the last problem because this is 1D and this is 2D. So we did this in our last lesson. In order for everybody to be happy, everybody has to be the same dimension. Right now those ratios are fighting. They're in a fight. You can't cross multiply them when they're fighting. Very good, Helaman. You need to square. 2D, 2D, 2D. Sounds like I'm saying 2D. Anyways, so 15 squared times 45 divided by 9 squared. So Quan, you're fired. It is 125 centimeters squared. You are not allowed to cross multiply an area with a side. You're just not. They're not proportional. So you need to adjust it. You have to square your sides. We've already done this lesson. We're just redoing it. We've already done this lesson in the similarity unit. Oh no! Your dog had an accident on your white carpet in your house and you can't get the stain out. You decide the carpet's got to go and you want to upgrade to hardwood floors. Your neighbor just had their floors remodeled with hardwood. The area of their room was 45 square feet and they paid $300. They got a deal. If the dimensions of your room are 3 times the dimensions of theirs, how much will your renovation cost? So the area of their room was 45, which actually we don't care about at all. They paid $300. So they paid $300. What kind of dimensions is that? Did they pay that for a perimeter, for a side, or for an area? Did they put hardwood along the perimeter of their room, along the side of their room, or the area of the room? Okay, so this value has to do with an area. Now your dimensions are 3 times theirs. Your dimensions. How many D is a dimension? It's 1D. So this value, the 300 is 2D, and this value is 1D. You cannot multiply those. It did not cost you $900. Your room is bigger than that. So what do you need to do? Good. You need to make it 2D, 2D. So it's not 300 times 3, it's 300 times 9. So your renovation, since your living room is so much bigger, is $2,700. Whereas theirs was only 300. That's what happens. When you do the length times 3 and the width times 3, your room gets a lot bigger. 9 times bigger, not 3 times bigger. All right. Just a reminder before you take your quiz. These are the special cases, remember? 30, 60, 90. Remember? 45, 45, 90. And 60, 30, 90. And these are your not special cases where you have to use trig. To find this angle, you would do 360 divided by double the sides, and that helps you find the angle. I think there's only one where you have to do trig. It's a short quiz and there's only one. It looks like this. Please fill out the form at home. And I will be emailing your teachers to figure out how to get that fixed at school. That's fine. Some of them have stars and some of them don't. So I asked you to answer that.